Welcome to Math and Computer series provided by Cup Java. Objectives today is by the end of this module, you will be able to describe free-falling object theory, and with that theory, translate a math equation into computer programming, specifically in Java. Our agenda today is Galileo's Leaning Tower of Pisa experiment, free-falling object equation, programming in Java. So we're going to delve into the first agenda of today, the Pisa experiment. As the story goes, this popular story, young Galileo is at the top of Pisa, preparing for an experiment that has been done before, according to the history, but he was the one who actually was able to analyze the results and came up with the amazing result, which in two different weights, two different objects of different weights, falling from the same height, they would eventually be hitting the ground at the same time, which kind of explains how the gravitational acceleration comes into a picture, 9.8 meter per second square. It is being debated still now today among scientists and mathematicians whether Galileo actually had done the experiment or conducted his experiment at the top of the Pisa. That's debatable. But what's not debatable is how he came up with the answer, how he came up with this, how he conducted his experiment, and how he came up with the answer by combining science and mathematics to analyze his results. That was amazing and undeniable, the impact in current science. So what was the previous belief? Previous belief is that those great great philosopher and scientist Aristotle, he stated that the heavier object will fall faster than the lighter weight object, which kind of makes sense. I mean, it's very intuitive if you think about it. If you drop a hammer at the same time a feather, what do you think will fall faster? Of course, hammer. But back then, no one knew anything about air friction, air resistance. And so to prove that in 1971, pretty recent, US astronauts went up to the moon and they conducted the same experiment. They dropped a hammer and a feather at the same time on the moon, and voila, they proved it. Those two objects of different weight came down onto the surface of the moon at the same time. So what I have here is a miniature version of Pisa, standing right there, and I have two different weights representing small one, lighter one, bigger one, that's heavier one. And my assumption here is that the distance between the top edge of the Pisa to the ground is 50 meter. And I did a little bit of research and I found out it actually is not 50 meters, it's about 47 meters. But for the sake of our experiment and our analysis, I made an assumption that it's a 50 meter. So what's the question today? The question is, assuming the height of the fall is 50 meter, how long would these two marbles take to reach the ground? That's our question, and that's going to be our main theme going forward. We're going to do a lot of understanding of the math part of it, and then once we have the understanding, we're going to go into programming that understanding into Java program. And here is our equation of free-falling object, h equals g times t squared over 2. Now we're going to get into more detail on the next slide. So our next agenda of the day is free-falling object equation. Our free-falling object equation is here represented here again. It's h equals g times t squared over 2. Now h is height of the fall. In our case, it's 50 meters. G is gravitational acceleration, which is 9.8 meters per second square. And then the t is the duration of the fall in seconds. So namely, t is the time that the ball starts to fall, and then when it hits the ground, that duration is represented as a t here. And another little bit of information before we move on. If we're talking about meters, we're going to be using 9.8 meters per second square for gravitational acceleration. But if we are somehow using feet and inches, we should be using 32.174 feet per second square. Those are the conversion factors, and it's very important. Our free-falling object equation is h equal g times t squared over 2. Now we all know g is 9.8 meter per second square, and our h is assumed to be 50 meter. What I want from here is to get something like that. So I want my equation, I want to use this equation to get to this result. How do I do that? Well, that's pure math. So I'm going to start by multiplying 2 to both sides. Right side of the equal sign, left side of the equal sign. So this will look like something like this. 2 times h equal g times t squared times 2 over 2. Now what's going to happen? So 2 over 2 will canceling each other out. So what do I have left is 2h over g times t squared. Now to go from here to here, there are quite a few steps left. So the first thing I need to do is to get rid of this g from next to t. So how do I do that? I'm going to divide left side of the equal sign with g, right side of the equal sign with g, so that I can cancel g out. Okay. And I'm running out of the room, so I'm going to start from here. So what do I have left? It's t squared equal what? 2h over g. Now we're closer, but not quite yet. I still have this, power there. So how do I get rid of that? You get rid of that by square root. So I'm doing the square root to the left side of the equal sign, doing the square root right side of the equal sign. So what you have would be t is equal to square root of 2 times h over g. So our equation now is t equal square root of 2 times h over g. We know h is 50 meter, g 9.8 meter per second square. So all we have to do is apply this number to h, apply that number to g. So I have 2 times 50 over 9.8, which is equal to 100 over 9.8. If you do that through your calculator, you'll get something similar to here, 3.19 some number of seconds. So next agenda, programming in Java. So we have the answer, we have the equation. Only thing that's left is to put that into programming in Java. So what was the question again? The question is, assuming the height of the fall is 50 meters, how long it would take? How long would it take for an object to hit the ground? And what do we know? We know the height, which is 50 meters, and we know the gravitational acceleration is 9.8 meter per second square. And last but not the least, the equation that we wanted to use is t. Time is square root of 2 times the height over gravitational acceleration. Before we jump into Java coding, I want to do something so that I have a plan, so to speak, plan of attack. So this is what we call flowchart. I'm pretty sure a lot of you may have experience with flowchart. Maybe not in computer programming context, but you may have it in literature or writing an essay or some kind of a science project. All right, so I'm going to start by drawing a circle. That's a start. Then next, what I'm going to do is I'm going to ask a user to input a height that they wanted to find out how long it would take an object falling from that height take. And usually that's being done in parallelogram. So input h. Then the next step. The very next step would be a processing, calculation. So processing is a rectangle. So our processing would be t is equal to square root of 2 times h over g. Okay, so we know h is input, g is 9.8 meter per second square. Then the next step, I'm going to be after getting the answer, which is t, another parallelogram, output, or instead of output, let's say print what? T. That's what we're looking for. And then we end our program. So this is my plan of attack. We start, we ask the question whether to put input a number, height, and then inside of the program we calculate the time, and then we present the answer to the user, and then we're going to end.